Hello, welcome to Darth Dragon Does Math. This is the first, I don't know, episode is the right word, but this is the first video of the school year, because it's 1.1. Guy didn't know, it's chapter 1.1. So what we're doing is we're going to learn how to represent rational numbers on the number line. And so I'm just going to jump right into it. I don't want to waste too much time. So, well, let me tell you what I'm going to do. I'm going to go over all these notes, and what I expect you to do is to follow along, write everything I write, and do so with a pleasant attitude, because you know you'll love it. Anyways, so we're going to start. We're going to find the absolute value of negative 11/12. And so most of us are relatively decent at absolute value. We recognize that these two bars right here are absolute value. So if I say negative 11/12, so I have the two bars on each side, and we're relatively sure that if I take the absolute value of something, that it just becomes positive. This one, if I want to find the absolute value of 26 over 15, 26 over 15, well, that's equal to 26 over 15. It was positive to begin with, so it's positive regardless. We might not be, however, familiar with why it becomes positive, and that's when we get into the definition of what absolute value actually means. Here, absolute value is absolute, I don't know how to spell it, absolute value is the distance a number is from 0. Now, the reason this is important and why it becomes positive is because there's no such thing as a negative distance. And think about it for a second. If I tell you to run somewhere, you've gone a positive distance. Even if you run around in a circle, you've moved a positive distance. Positive. There's no such thing as going backwards. And if somebody figures it out, please let me know, because there's a few things that happened back in 1997 I'd like to take care of. Okay, so and I'm just going to do this real quick. So if I have 26 over 15, I want to actually convert that into an improper fraction real quick. Not an improper fraction, a proper fraction, a mixed number fraction. So just a reminder how we do that. We say 26 and 15. Every 15 out of 15 is 1. So this is 26 over 15 is like 15 over 15 plus, what is it, 11 out of 15. Now, if you don't know where I got that, think of it as 15 plus 11 is 26, and our denominator is always the same, which is equal to 1 and 11/15. And we could do that in a calculator too. I want to show you both. I don't know if we could see that. If I say 26 divided by 15, I hit enter, it's going to give me a decimal. If I don't want that decimal, I can hit second, PRB right here. Second means that I'm going to this word up here, and that's F to D, which means fraction to decimal. I'll click that and enter. I've got my fraction, 1 and 11/15. So that's what I wrote right here. So, all right. So if I want to represent negative 11/12 and 26/15 on the same number line, and then I want to figure out which one is closer to 0. So what I'm going to do is I'm going to say, all right. So let's make a little number line here. Put 0 in the middle. 1, 2. That was not the best. And so this is -1, this is -2. I'm going to put both of these on the number line, how these originally started. So negative 11/12, so I'm going to put that on a number line. So this is almost 12 out of 12, which would be -1, but it's not. So if this was negative 6 twelfths. I get halfway there. Negative 11 twelfths is about right here. I got distracted. Okay, so if we go back, there's 12 check marks here. Negative 11 twelfths is right here. If I want to do 26 over 15, remember that is the same thing as 1 and 11 fifteenths. So this is like 1 and 11 fifteenths. So it's be around here somewhere. So what I'm going to do is I'm going to make sure there's, so this is 5 fifteenths, this is 10 fifteenths, 11 fifteenths is going to be right there. So that is 1 and 11 fifteenths. Now we want to know which one is closer to 0. So if I think about distance, that's from here to here. And distance, this is going to be from here to here. And hopefully it's very clear that 1 and 11 fifteenths is further from 0. And I do all of this to bring up, you know, a lot of times in math class, what you're going to say is which one is greater. Well, you can see because based on distance, or maybe we know that this one is greater than 1, but negative 11 twelfths, if I took the absolute value of it, it would be less than the absolute value of 26 over 15. All right. Right here, we have Padawan questions. So this is basically like guided practice. So I've done a few examples. Now I want you to practice doing something similar here. Yes. Okay. And by the way, if you ever want to practice, just stop the video because I don't know how long it's going to take. I can't just pause it myself. All right, so here I want to write each number in m over n form where m and n are integers. Okay, so what m over n form means that I'm going to take a number, say 23, and I'm going to write it like a fraction, like a ratio. These are rational numbers. Now, why that's important is because the root word of rational is ratio. These are numbers that can be represented as ratios or fractions. So if I take 23, where 23 as a fraction is 23 over 1. Any whole number, you just take the whole number and you put it over 1. So if I have negative 45, that's negative 45 over 1. This right here, this is 11 and 7/9. Well, that is not in m over n form. I can't have this 11 here. That's got to go away. So instead, what I'm going to do is I'm going to change this into an improper fraction. In fact, you'll probably hear me tell you about 100 times in class that I don't like mixed number fractions very often. In fact, I love improper fractions. So what I'm going to do to turn this into an improper fraction is we take the denominator, we multiply it by the whole number, so 9 times 11, and then we add whatever the numerator is, so plus 7, and we put that over the denominator to begin with. So this is 9 times 11, which is 99, plus 7 over 9, which is 106 over 9. And now we are in m over n form, so we're good here. This right here, negative 16 over 21, guess what? That is literally already in m over n form, so we're done. We don't have to do anything with that, just like 24 over 10. We don't have to do anything. So you can practice doing those right there. And our last little examples here are taking a rational number that is a decimal and converting it into m over n form. So I'll teach you how to do this. So a quick, simple way to do any of this is to take the number, however many of the digits are behind the decimal, that is, you will put it over a 1, so this is 0.4 over 1 to begin with. Then what we do is we take however many the decimals numbers are behind the decimal and we move it to the right, and that becomes 4. But we take this decimal and we move it to the right and add a 0. So this becomes 4 over 10. Or another example would be, okay, if I had 0.6, that's 6 over 10. If I had 0.61, this would be 61 over 100. And I hope you get the point there. We just, however many are behind the decimal, that's how many zeros we have behind the 1. So this is 4 over 10. Now, that's fine. The only thing is, this is a math class, and I do expect you to simplify the decimal. So 4 over 10 can be simplified. I can divide both 4 and 10 by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So I get, this becomes 2/5. This one right here, negative 0.186. Well, that's the same thing as negative 186 over 1,000. Now I can simplify that, but the reason it's 1,000 is because, again, there are 3 numbers right here behind the decimal, so I need 3 zeros. And let's take another step back and remember, this number, if you say it out loud, it's not 0.4. Technically, it's 4/10. 4/10. This number, if you were to say it out loud, it would be negative 186 thousandths. Negative 186 thousandths. This number right here, this is 30 5/10. So it's technically 305 over 10. This one right here is negative 148 over 100. And we can simplify all of these. This one right here, I can divide both by 2. Let me show you how to do it in your calculator, though, which is kind of neat. Shine some light on that. If I have negative...
Teachers and students, pardon the interruption. I have an announcement from the athletic director. Every person who plans to attend tonight's Pride Night / benefit game will be required to pay $4 cash. So unless you have $4 cash, they won't let you into the game tonight. Just wanted to pass that message along. Thank you.
Hopefully you got that message before the Pride Night tonight. Anyways, sorry. Negative 0.186. If I hit second F to D again, and I change that to a fraction, I will get negative 93 over 500. And you know what? That is what this is. If I divide 186 by 2, I get 93. And we want to make sure it stays negative. 1,000 divided by 2 is 500. This right here, both of these numbers are divisible by 5. 305 divided by 5. Well, I don't know that off the top of my head. I mean, I can do it. I can say, okay, 5 goes into 36 times. 5 goes into 5 once, so that's 61. 5 goes into 10 twice, 61 over 2. And then this one right here, I can say, all right, so divide each of these numbers by 2. Negative 148 divided by 2 is 74. So this is negative 74. 100 divided by 2 is 50. I can still simplify that more. Divide by 2, divide by 2. Negative 74 divided by 2 is 37. Negative 37, and this is 25. Again, that's nice. Let me teach you how to do it in a calculator as well, though. So if I said negative 140, let's start with the point. Negative 1.48, because that's what I started with. I hit enter. it's going to tell me negative 1.48, and we're all going to be like, well, duh. But if I hit second PRB and I change it to a fraction, well, now I'm in a mixed number fraction. I don't want a mixed number fraction. So then I can hit second ABC, and what this is going to do is to change a mixed number fraction to an improper fraction, or an improper fraction back to a mixed number. If I hit enter there, enter, negative 37 over 25. And should I remind you, negative 37 over 25 was my correct answer. So that is the end of my examples. You can try these out down here. I will leave you with my common statement, which is math. Goodbye.